This question is given in GATE 2007. Okay, now see this question. In the CMOS inverter circuit, if the transconductance parameters of the NMOS and PMOS transistors are Kn equal to Kp equal to mu n cos x Wn by Ln is equals to mu p cos COSP Wp by Ln is equals to 40 microamps per V square, and the threshold voltages given as Vth equal to Vtp equal to 1 volts, and they are asking what is the value of current I. They are asking what is the value of current I flowing in this circuit. They have given 4 options. Option A 0 amperes, option B 25 microamperes, option C 45 microamperes, and option D 90 microamperes. Okay, now you observe here, this is the input voltage given here. It is 2.5 volts. It is VDD. This is the drain of the first transistor. This is gate. This is also gate. This is the source. This is indicated by VSS. VSS is nothing but 0 volts, since ground will be at 0 volts. If you observe this voltage, V in is VDD plus VSS by 2, exactly half. 5 plus 0 by 2, that is equals to 2.5 volts, which is as same as the applied input voltage. Means we can say that this is the inversion point. This is called as inversion point. Very important point, you should remember. Okay. Now, at this inversion point, there were 2 things that may happen. If V in is less than V inversion point, then obviously V0 should be greater than V inversion point. Okay, otherwise V in greater than V inversion point, then V0 should be less than V inversion point, but both the transistors are in on state. Both transistors are in on state, and saturation state. So this is the one of the important point you should keep in mind. At V inversion point, whenever the applied input voltage is less than that, output voltage will be greater than that. Otherwise, vice versa, when it is greater than V inversion point, output voltage is less than V inversion point, and both the transistors are in on condition, which means here IDP is the current flowing through this PMOS transistor, and IDN is the current flowing through NMOS transistor. From this we can say that as these both transistors are in series to each other, IDP is equals to I is equals to IDN. That thing we can say, because both the transistors are in series. Since both PMOS and NMOS are in series, we can say that IDP is equals to IDN is equals to I. Now, if we calculate either IDP or IDN, that itself is nothing but I flowing in this circuit. Okay. Now, we get the drain current equation for P. Drain current equation can be given by drain current equation. IDN is equals to K into VGN minus VTN, VGS n minus VTN whole square, and the value of K, Kn they are given as 40 microamperes. This will be equal to 40 microamperes into VGN minus VSN minus VTN whole square. Okay, this will be equal to 40 microamperes into VG. Here we are giving 2.5 volts to VG. Okay, so 2.5 minus Vs is nothing but it is 0 volts. 0 volts minus VTH threshold voltage they are given as 1 volt. So 1 volt whole square. This will be equal to 40 microamperes into 2.5 minus 1.5 whole square. Sorry, 1 whole square. This will be equal to 40 microamperes into 1.5 whole square. This will be equal to 40 microamperes into 2.25. So if you calculate this, this will be 90 microamperes. That is the value of IDN. So if you look into the options, it is option D, 90 microamperes. Since IDN is nothing but just I, which is the required value. Okay, now I got the solution. How we got the solution is, you see this diagram, 2.5 volts is exactly equal to VDD 5 volts plus VSS 0 volts divided by 2. Means it is exactly dividing this VDD plus VSS. So this point is called inversion point. At this inversion point, both the transistors are in saturated and in on condition. So as they are in series, the current flowing through them should be same. So IDP is equals to IDN equal to ID. From the drain current equation, IDN is equals to K into VGS of N minus VT of N whole square. So by just simply substituting the values from the given set of data, so we have simplified that, we have got it as 90 microamperes.